Okay, good morning. Today we are going to start the remaining part of the design procedure of roof truss. I think we have covered total 7 steps up to the calculation of the dead load. So today we'll start the step number 8, that is calculate live load. So we have seen the various types of load coming on the roof truss: dead load, live load, and wind load. so how to calculate live load? So that live load we have to calculate, that is W is equal to 750 minus theta minus 10 into 20, that is Newton per meter square. That load is given in IS code. So in this way we can calculate the live load. So this is the formula for calculation of live load: 750 minus theta minus 10 into 20 Newton per meter square. So if we have to calculate this live load in Newton, then so total live load is equal to total live load is equal to live load into plan area of roof truss. Plan area of roof truss. So total live load is this W into, we have to multiply by plan area. So plan area of roof truss is nothing but here. So we have seen in the dead load calculation. In the dead load calculation, plan area of roof truss is span by 2 into spacing of truss. This is in Newton. So now here total live load is in Newton. How? Because this live load W, because theta is known. So if put here theta value, then W, this live load, will get in Newton per meter square. If we multiply plan area of roof truss, so area of roof truss is in meter square or mm square. If we multiply this plan area in meter square, then meter square and meter square get cancelled, and we will get the value in the Newton. So total live load on the roof truss we will get in the Newton. So now, so we have to calculate live load on the intermediate panel point, similar to dead load. See, go to back and see the dead load, how we have calculated dead load on the panel point. So we have to calculate dead load on intermediate panel point and end panel point. So similarly, we have to write here live load on each intermediate panel point is equal to total live load. So this is total live load. This is total live load. So total live load divided by number of panels. So we have assumed the number of panels. We are assuming number of panels 3, 4. So we have assumed in the dead load calculation number of panels. So total live load divided by number of panels, we will get the live load on each intermediate panel point. Then we have to calculate live load on each end panel point. So we have draw the sketch for dead load, intermediate panel point and end panel point. So live load on each end panel point is equal to live load on each intermediate panel point divided by 2. So in this way we can calculate the live load calculation, or we can see the live load calculation. So first we have to calculate total live load by using this formula and multiplying by plan area of roof truss. Then we have to calculate the live load on each intermediate panel point and live load on each end panel point. So where are these intermediate panel point and end panel point? So if you draw this truss, everyone please draw this. So this is the truss and these are the panel point. So this and this one is the intermediate panel point. So here these are the intermediate panel point. So this load, this live load on each intermediate panel point, so this calculation comes here. So these are the intermediate panel point and this is the end panel point. So whatever load calculation will come here, that load calculation we have to show here. या मधल्या तिन्हीला हे तुम्हाला load calculation दाखवायचं आहे. So similarly, right side will be same. So again, these are the 3 intermediate panel points. Intermediate panel point. And so this is here again 2 purlins are there. So here these are again end panel points. This is end panel. Why on this end panel half load is there? Whatever load in coming on the intermediate, whatever load coming on the intermediate, that intermediate divided by 2 means exactly half load coming on this end panel, because whatever this length is there in this area, half load going this side and half load going this side. On this point, half load of this part and half load of this part. So total this load, this area load is coming on this point. This area load is coming on this point. So here only on this end point, this load only coming. So half load is there. Intermediate panel point वरती येणारा जेवढा लोड आहे त्याचा हाफ लोड हा एंड पॅनल पॉइंट वरती जातो, कारण हा अर्ध्याच एरियाचा लोड या एंड पॅनल वरती जातो. आणि इथं इंटरमिडिएट पॅनल पॉइंट वरती काय होतं, इकडचा अर्धा एरिया आणि या बाजूचा अर्धा एरिया असा दोन्ही मिळून ह्या इंटरमिडिएट वरती जातो. त्यामुळं लाईव्ह लोड ऑन इच इंटरमिडिएट पॅनल पॉइंट म्हणजेच काय केलं, टोटल लाईव्ह लोड इथं काढलेला टोटल लाईव्ह लोड डिवाइडेड बाय नंबर ऑफ पॅनल. पॅनल मीन्स this is 1 panel, this is 2, this is 3 and this is 4. So total 4 panels are there in this half truss. या हाफ ट्रस मध्ये 4 पॅनल आहेत, मग आपण इथे 4 ने डिवाइड करायचं. सो टोटल लोड डिवाइडेड बाय 4 केलं तर प्रत्येक पॉइंट वरचा आपल्याला लोड मिळेल. सो दीज आर दी 3 इंटरमिडिएट पॅनल and exactly half load of this intermediate panel is the end panel load. Are you getting? So this is live load. Are you getting? टोटल लोड काढायचा, टोटल लोड नंतर इंटरमिडिएट पॅनल पॉइंट वरचा लोड काढायचा. तो कसा काढला, टोटल लोड डिवाइडेड बाय नंबर ऑफ पॅनल. सो दीज आर दी नंबर ऑफ पॅनल 1 2 3. पॅनल मीन्स दिस 1 पॅनल, दिस इज 2 पॅनल, दिस इज 3. म्हणजे सपोर्ट टू सपोर्ट. panel point distance, this is one panel, 2, 3 and 4. So 4 डिवाइड केले की आपल्याला इंटरमिडिएट पॅनल पॉइंट वरचा लोड मिळेल. आणि इंटरमिडिएट पॅनल पॉइंट वरचा लोडला जर डिवाइडेड बाय 2 केलं तर एन पॅनल पॉइंट वरचा लोड. आर यू गेटिंग? दिस इज द live load calculation. Okay, everyone please draw this. So we have to solve the example after this procedure. Okay, now next is the step number 9. So step number 9 is calculate wind load. So we have did the calculation of dead load, live load, now calculation of wind load. So this is very important load calculation in the design of roof truss, because we are providing this roof truss for the industrial side. So industry is a very large area building is there. So on this large area building, so major load is coming on the industrial side is the wind load, because as compared to our regular building, the very much high width and length of industrial building is there. So why industrial building we are providing truss, roof trusses, this. So the wind load calculation is very important. So okay, so we will see how to calculate the wind loads coming on the truss. Okay, so as we have seen, but we have to calculate first in the wind load calculation, that is small a. So we have to calculate first. So write down before the calculation, write down one sentence here. Let us assume, life of building. Let us assume life of building or industrial building. Write down industrial building to be 50 years, and land to be plain, and surrounded by small building. This we have to assume because for this 50-year life, so K1, K2 factors are there. K1, K2, K3 factors are there for this 50-year life. So that we will see. So we have to assume first at least the life of building is a 50 year. Now we have to calculate first basic wind speed. We have seen this at the time of load calculation, types of load we have seen. Before this lecture, we have seen the types of load. In that, we have seen this dead load, live load, and wind load. So basic wind speed. First, we have to calculate basic wind speed, that is VB. So how to calculate VB? So VB is equal to, that depends on, write down, depends upon. So this part is very important for MCQ examination. Whatever I am writing now here in wind load calculation, so this is very important for MCQ examination, because one of MCQ every time asked on this wind load calculation. So depends upon region, where building is to be located. So that basic wind speed VB in meter per second is depends on the where your building is located. So on the page number 125 steel table. So maybe page number will be changed, but uh, page 125 steel table. So for in India, for each city they have given the basic wind speed. On page number 125 steel table, you can see, if you have steel table, you can see the VB value, wind speed on particular area. So in steel table they have given for our Pune region only they have given uh, wind speed. So if in examination they ask your building is located in Solapur, so we have to take the wind speed for the Pune region. आपल्या जवळचा जो सिटी आहे त्या सिटीचं आपण विंड स्पीड घ्यायचं. मग इट मे बी युअर बिल्डिंग लोकेटेड इन पटना, युअर बिल्डिंग लोकेटेड इन नागपूर, चेन्नई. सो एक्झाम्पल मध्ये जिथं बिल्डिंग तुमची लोकेटेड सांगितले त्याच्या जवळपासच्या सिटीचं दिलं असेल तर ते wind speed घ्यायचं. So that VB you have to take from this page number 125 steel table. Okay. In examination, the location of building is given. Your building is located any of the city in India as given in the problem statement. Okay. So VB how to calculate? So it depends upon location of city. कुठल्या सिटी मध्ये तुम्ही हे डिझाईन करताय रूफ ट्रस, त्या सिटीचा बेसिक विंड स्पीड त्या सिटी मध्ये किती आहे तो आपल्याला इथे घ्यायचा आहे. सो VB इज वेअर ओव्हर. नाउ स्मॉल b is design wind speed. Design wind speed. So design wind speed is nothing but Vz. So how to calculate Vz? So Vz is equal to this K1 into K2 into K3 into this VB. So VB we have taken from here. Now K1, K2, K3, these are the factors depend upon this whatever statement we have written. So these factors generally they are given in the examination on the problem statement, or we can find from the IS code. So for wind load calculation, here IS 875 part 3 is there. So for wind load calculation, IS 875 part 3. So third, we have to record in examination, theory examination, IS 800 2007 steel table and IS 875 part 3. For only this wind load calculation, this IS code is required. So maybe in examination MCQ will ask which IS code is required for this wind load calculation. So IS 875 part 3. The answer is IS 875 part 3. This IS code is required for wind load calculation. Live load calculation part 2 and dead load calculation part 1. 875 part 1 for dead load calculation, 875 part 2 for live load calculation, and 875 part 3 for wind load calculation. Maybe any one question you may ask in examination, part 1, part 2 and part 3, which IS code is required for dead load, which IS code is required for live load, or which IS code is required for wind load. So IS 875 part 1, 2 and 3 for dead load, wind load and live load. So many times such questions are asked in examination on this IS code. Okay. So now K1, K2, K3 values are available in this 875 part 3. So from this IS code or maybe in examination they are given directly. So K1, K2, K3, these are the factors we have seen in detail. What are these factors? Then, so the wind speed is over. Now see design wind pressure. Design wind pressure. That is PD we have to find out. We have find out first wind speed. From wind speed we have calculated design wind speed, basic wind speed. From basic wind speed we have calculated design wind speed, and from design wind speed, here instead of speed we can write velocity also. Basic wind velocity म्हणू शकतो आपण इथं. Instead of speed we can tell velocity. Then from this velocity we can calculate design wind speed Vz, and from this Vz now we can calculate design wind pressure, whatever actual wind pressure coming on our industrial shed. So how to calculate this? So PD is equal to 0.6 Vz square. So this is also very important related to MCQ examination. Many times this PD is equal to 0.6 Vz square. Okay, so design wind speed we have calculated now. Now wind pressure is there. Now we have to calculate wind load in Newton. So next point is the D point that we have to calculate. Calculate height to width ratio. Height to width ratio. So write down this properly, because this roof truss design, you have to design this roof truss in next semester also. You have project on this roof truss, industrial shed वरचा प्रोजेक्ट तुम्हाला पुढच्या सेमिस्टरला आहे. त्यामुळे हा प्रॉब्लेम तुम्हाला समजणं आणि येणं खूप गरजेचं आहे. 50 मार्काचं टर्म वर्क असणार आहे फक्त या रूफ ट्रस वरती तुम्हाला नेक्स्ट सेमिस्टरला. सो प्लीज एव्हरीवन राईट डाऊन this properly. So calculate height to width ratio. So height to width ratio means we have to calculate h by w. So h by w, h is the height of your industrial building and w is the width of industrial building. Width means this is your width. ही तुमची ट्रस असेल तर हे ट्रसची width, or we can say span. This is your w, span of your truss, and height is the total height of building. So this is the total height of building. So this is your h. Are you getting? So h by w ratio you have to calculate. So I will say for what we have to calculate, what purpose we have to calculate this h by w ratio. Okay, so h by w ratio we have to calculate now. Okay, now let us assume the building, to have normal permeability. For normal permeability, for such condition, next line small a, internal wind coefficient, write down first, then I will tell you. Internal wind coefficient is 0.2 p, and for this normal permeability, sorry, plus minus 0.2 p, and external coefficient, external wind coefficient, that is this is CPI. Internal wind coefficient is CPI and external wind coefficient is CPE. So given symbols are CPI, internal wind coefficient is CPI and external wind coefficient is CPE. So now this, so what is this internal wind coefficient and what is external wind coefficient? So why this coefficient are required? We are calculating wind pressure, but what is this coefficient and why these coefficients are required? So IS 875 part 3. So there are, if you see, this is the your industrial shed or truss. So if the direction of wind, this is the direction. If the direction of wind this side, so this side we are calling as a windward side, windward side, and this is leeward side. See, please concentrate here. If your truss is like this and the direction of wind in this direction, so ज्या डायरेक्शन वरून विंड येते त्या डायरेक्शनचा जो स्लोप आहे त्याला आपण विंडवर्ड स्लाइड म्हणतो किंवा विंडवर्ड स्लोप म्हणतो. त्याच्या अपोजिट डायरेक्शनचा जो स्लोप आहे त्याला आपण लीवर्ड स्लोप म्हणतो किंवा लीवर्ड साइड म्हणतो. आर यू गेटिंग? सो या बाजूला प्रेशर जास्त असतो. सी इफ वी कंपेअर दी अदर साइड. बघा मी काय सांगतोय, जर या बाजूने जर प्रेशर विंड तुमची येत असेल तर ऑब्वियसली या बाजूला विंड प्रेशर कमी असणार आहे अदर साइडला. सो दिस साइड वी आर कॉलिंग एज अ विंडवर्ड साइड and this side we are calling as a leeward side. So due to this windward and leeward, the pressure जर या बाजूला जसा असेल तो या बाजूला नसेल, म्हणून त्याच्यासाठी IS 875 पार्ट 3 मध्ये कोएफिशियंट्स दिले. सो कोएफिशियंट्स, या कोएफिशियंट्स वरून त्याचा प्रेशर कॅल्क्युलेट केला जातो. सो एक्सटर्नल कोएफिशियंट्स CPI म्हणजे जेवढा काय विंड प्रेशर येणार आहे त्या विंड प्रेशरला या कोएफिशियंटने मल्टिप्लाय केले जातं आणि इकडे जेवढा येणार आहे त्याला पण लीवर्डने केलं जातं. तर आता त्याच्यासाठी तुम्हाला लीवर्ड आणि विंडवर्डचा मी इथे टेबल तयार करावा लागेल किंवा IS कोड तुम्हाला मी सेंड केले होते. IS कोड आहेत का तुमच्याकडे? तो मी मेलला तिन्ही IS कोड सेंड केले, IS 800, IS 75 आणि स्टील टेबल हे सगळं सेंड केलं होतं तुम्हाला. ओके, सो we will see first what is windward side, what is leeward side, आणि wind normal to ridge and wind parallel. थोडासा डिफिकल्ट पार्ट आहे बट कीप इन युअर नोटबुक. ओके, सो जर नॉर्मल परमेबिलिटी जर आपण अज्युम केली तर इंटरनल कोएफिशियंट्स हा 0.2 p प्लस मायनस 0.2 p. इट मीन्स व्हॉट? तर या ठिकाणचा कोएफिशियंट इथं 0.2 p प्लस मायनस 0.2 p कोएफिशियंट इंटरनली असतो. सो दिस इज इनसाइड, this is external side. So this is internal side and this is your external side. Is a true truss असेल, so this is internal side and this is external. So internally we are assuming plus minus 0.2 p. Always we are assuming plus minus 0.2 p. So when plus and when minus, plus is nothing but what and minus is nothing but what. If your if we assume this point 2p, when minus, if your truss is lifting, if your truss is lifting, then minus 0.2p pressure, and if this your root truss is downward direction, then your pressure is plus 0.2p. प्लस 0.2p प्रेशर कधी असतो, ज्यावेळी तुमची डाऊनवर्ड साइडला तुमची ट्रस विंड प्रेशर मुळे प्रेशर हा डाऊनवर्ड साइडला असतो, त्यावेळी प्लस 0.2p प्रेशर असतो इंटरनली, आणि इंटरनली मायनस 0.2p प्रेशर कधी आपण कन्सिडर करतो, ज्यावेळी ट्रस तुमची लिफ्ट होत असते. जरी विंड प्रेशर तुमचा डाऊनवर्ड असेल तर इंटरनल पण प्रेशर काहीतरी आहे, फक्त एक्सटर्नलीच विंड प्रेशर येत नाही, इंटरनली पण थोडा प्रेशर असतो. सो दॅट इंटरनल प्रेशर वी आर अज्युमिंग प्लस मायनस 0.2p. सो यू कॅन बेटर अंडरस्टूड व्हाईल कॅल्क्युलेशन ऑफ दिस. आपण ज्यावेळी कॅल्क्युलेशन करू इंटरनलची आणि एक्सटर्नलची, त्यावेळी तुम्हाला डिटेलमध्ये समजेल. सो दिस इज दी कोएफिशियंट्स. नाव अगेन इन दिस बी वी हॅव टू कॅल्क्युलेट विंडवर्ड कोएफिशियंट फर्स्ट. आता इंटरनल कोएफिशियंट प्लस मायनस 0.2p आपण अज्युम केले आणि हेच घेतो आपण इंटरनली. एक्सटर्नली आपल्याला कॅल्क्युलेट करायचे. जसं इंटरनली प्लस मायनस 0.2p आपण कन्सिडर केला, तसं एक्सटर्नल विंडवर्डचा आणि लिवर्डचा कॅल्क्युलेट करायचा आहे. आणि हे कोएफिशियंट कॅल्क्युलेट केल्यानंतर आपल्याला आयएस कोड मध्ये या कोएफिशियंटच्या व्हॅल्यू दिलेल्या आहेत, त्या व्हॅल्यू आपल्याला कॅल्क्युलेशन मध्ये घ्यायच्या. ओके, सो कसं कॅल्क्युलेट करायचा एक्सटर्नल विंड कोएफिशियंट. सो इन दॅट वन इज दी on windward side, on windward slope coefficient, windward slope coefficients. So how to calculate windward slope coefficients? So windward slope coefficients CPE is equal to windward coefficient जो तुम्हाला आयएस कोड मध्ये दिलेला आहे, मायनस विंडवर्ड कोएफिशियंट मायनस difference of windward coefficients divided by difference of slope just a minute. So these are the only formulas I am writing. These formulas are there into obtain slope minus minimum slope. So what is this actually? Windward coefficient कुठे आणि कसे असतात ते मी एक एक्झाम्पल सांगतो. जनरली